Alright, so today let's look at simple equations. Alright, or rather the actual name of the chapter will be simple linear equations. Alright, and true to its word, it is simple. Alright, so trust me, one of the easiest chapters. Now, anybody who knows what is the meaning of linear or linear equation? Anybody?
Like left hand side equals right hand side.
That is the meaning of an equation.
Like next to each other.
No. Any other guess?
Separated by the equal sign.
That is an equation. I'm talking about what is linear. See, you all are right on one count that an equation has a left hand side, let's call it LHS, and a right hand side, and they both are equal. That is why we call equation equal or equality. But what do you mean by the term linear? What is linear? Linear, if you look at the geometrical name, alright, and the meaning, it means a line, right? Don't we use the word linear pair, right? Forming a straight line. But in algebra, when we talk about simple linear equation, it means an equation, alright, whose power is 1 or degree of the variables is 1. That means we are not going to be dealing with variables of anything, any power more than 1, greater than 1. So a linear equation would not be something like this: x square plus 2xy plus 3x cube. This is not a linear equation. Alright? Getting me?
Yeah.
Why? Because if you look at the power or the degree of this polynomial is 3. Right? So that means this is a cubic equation because it is cube. Correct? But linear equation has degree 1. So for example, there will be an equal to sign. For example, let's say I have 3x plus 5 equals to 12. So this is a linear equation. Why? Because it has a left hand side, it has a right hand side, they are equal, and the power is 1. So we are dealing with as simple as such kind of questions. Alright? Now let's look at some simple examples on how we are going to solve the linear equations. Right? Let's take this example forward. 3x plus 5 equals to 12. So we have to find the value of x. That means what we have to do is we have to keep only x on one side, take all other terms onto the other side. Alright? Including this coefficient of x. So Prachi, what is the first value that we will take?
5.
Correct. Now see, if you notice, it is plus 5 over here. Correct? It is
Yes.
plus 5. So this plus 5, when it goes over to the right hand side, it crosses this equal to sign, which we can treat it like a magic bridge. Right? And when the plus sign crosses over to the right hand side, or from one side to the other side, it becomes negative 5. So when it goes over here, it becomes 12 minus 5. And here what will we be left with on the left hand side? 3x. So 3x equals to 12 minus 5. So I can find out what is 12 minus 5?
Yeah.
That is 7. Now I will take 3 over there. Now can you tell me 3x, what is the operator connecting 3 and x? Multiplication. Correct? That means it is under multiplication.
Yeah.
Correct? So now when I take this 3 over to the right hand side, it will turn into division. Now when multiplication becomes division, or when division becomes multiplication, remember the sign does not change. If it is positive, it remains positive 3. Had it been negative 3x, had it been this way, minus 3x equals to 7, had it been this way, and I would have taken minus 3 over there, since it is under multiplication, I would get x equals to 7 upon minus 3.
Yeah.
So the signs do not change when we go from multiplication to division and vice versa. Hence over here we will get x equals to 7 upon 3. Are we clear?
Yeah.
Now if our final answer is an improper fraction, what do I mean by an improper fraction?
The numerator is greater than the denominator.
Correct. So since here 7 upon 3 is an improper fraction, I will convert it into a mixed fraction. So 3 2s are 6, remainder 1. Hence it will be 2 integer 1 upon 3. This is my answer. This is the value of x that we have been looking for. Simple, easy.
Yeah.
Yes. Now let's look at different variety of equations. Alright. So with each question we will go a level up, alright, a level higher, so that we understand the complications that could come in a simple linear equation chapter. Alright. So let's take another example. X upon 3 minus 8 equals to 10. Now over here I will take minus 8 over to the other side first. So I'll be left with x upon 3 equals to, since it is subtraction over here, it becomes addition plus 8. So I will be left with x upon 3 equals to 18. Now when I take 3 over to the other side, here on the left hand side it is division. So on the right hand side it will become multiplication. So x will be equal to 18 into
50.
So over here 3 is positive, it remains so. Hence my value of x will be
54.
54. Simple?
Yeah.
Yeah. Can you say still a very simple chapter? Yes? Okay. Let's look at another one. Let's say I have 5x minus half equals to 3 upon 4. Now here I will take this minus 1 upon 2 over to the other side. So it will become plus 1 upon 2. So subtraction becomes addition. So plus 1 upon 2. Are you with me?
Yeah.
Now don't forget the previous chapters on fractions. How do we add two unlike fractions? By making them like fractions. So I will multiply 1 upon 2 by 2 divided by 2. So multiply both the numerator and the denominator by 2. Right? Hence I will get 5x equals to 3 plus 2 the whole upon 4. So 5x equals to 5 upon 4. Pay attention. Now I will take this 5 over to the other side. Now here it is multiplication, so it will become division. So the way I can write it is, since it's a fraction, the 4 is there in the denominator, I can take this 5 and put it in the denominator, write it as 5 upon 4 into 5. Right? If you are not comfortable with this method, alright, let's say it can get confusing for some of us, then you can also take this 5 over to the right hand side and write it as 5 upon 4 into 1 upon 5. Got it?
Yeah.
So basically here 5 is in the numerator, on the right hand side it will come in the denominator. So in both the cases 5 will get cancelled out
Yeah.
and I will get the answer as 1 upon 4. Now here we all need to be very careful. Okay, a common mistake that a lot of students make is that even though the 4 is in the denominator, they write it as 4 instead of 1 upon 4 as the answer. So this is something that you better watch out. Alright? Yeah, so if your value is left in the denominator, let it be in the denominator. If the value 4 is in the numerator, then it is to be written in the numerator. Right? So your answer should be x equals to 1 upon 4, not 4. Is that clear?
Yeah.
Simple, easy. Yeah. Now see, all these equations that we had, alright, had variables only on one side, either the left hand side or the right hand side. Correct? Now let's say if we have variables on both the sides, left hand side and right hand side. Then how do we go about solving it? So let's take a very simple example. 8x minus 3 equals to 5x plus 9. Alright. Now over here, my challenge would be to make sure that all the variable terms come on one side and the constant terms come on to the other side. Right? So if I notice 8x is on the left hand side, 5x is on the right hand side. Correct? So I can take either 5x on the left hand side or I can take 8x on the right hand side. Either ways is absolutely fine. So you can choose what to do as per your comfort level. Alright? So let me take 5x over to the left hand side because छोटू हमेशा मोटू के पास जाता है. Correct?
Yeah.
So the smaller fellow always goes to the bigger fellow. Right? So 8x, now 5x, I'm taking the term 5x over to the other side. So what will happen to it?
Negative.
Negative 5x. Because if you notice over here, it is the term is 5x plus 9. That means it is in addition. So when I pick it up and take it over to the left hand side, it will become subtraction. And likewise, in the same breath or in the same step, I will pick negative 3 and move it to the right hand side, which will become positive 3.
Yeah.
Now 9 is where it is not moving, so it will remain the way it is. So it is positive 9, so it will remain positive 9. See, the term that does not move, its sign does not change. Like we didn't move 8x. 8x was on the left hand side, it remained on the left hand side. Correct?
Yeah.
Yes? And we moved 5x, so 8x minus 5x. Now here on the right hand side, we did not shift 9 anywhere. So it remains positive 9, and I take negative 3 over to the right hand side, it becomes positive 3. Now it becomes a very simple solution. What is 8x minus 5x?
3x.
3x. So 3x equals to
12.
12. Now it becomes like the previous question, right? There's only one variable on one side. Now I will take this 3 over to the right hand side, it will become division. So x will be equal to 12 upon 3. 3 ones are, 3 fours are. Hence my answer is x equals to
4.
4. Are we clear?
Yeah.
Is this understood?
Yeah.
Absolutely clear?
Yeah.
Super. Let's look at another sum. Now let's look at a sum which involves a little bit of brackets as well. So BODMAS will come into play. Not that BODMAS was not applied over here, it was definitely applied over here, but more prominently so in this particular example that I'm about to give you. 2 into bracket x minus 5 plus 3 into bracket x minus 2 bracket close equals to 8 plus 7 into bracket x minus 4. Right? Now don't forget the rules of BODMAS. So we are going to apply BODMAS over here. So first it's brackets, so we solve the brackets. Now if you notice in each of the brackets there are unlike terms, x minus 5, x minus 2, x minus 4. So we cannot solve anything inside the bracket. That means now we have to open the bracket right? And we will take this 2 and multiply it with the first bracket x minus 5. Then take this 3, multiply it with this bracket x minus 2, and take this 7 and multiply it with the bracket 8 x minus 4. The 8 stays the way it is. So remember, this 2 has to be multiplied with every term in the bracket. So it will become 2x minus 10.
Yeah.
Now see, there is positive 3. We also need to take into account the sign that the number has. Since it is positive 3, we don't have to worry. Alright, now this will become plus 3x, and 3 into minus 2 will become minus 6. So always remember to take care of your pluses and minuses. Alright, here we apply the rule: positive number multiplied by a positive number gives us a positive number. Positive number into a negative number gives us a negative number. Come on, get some energy. And a negative number multiplied by a negative number, positive. Don't forget that, you made that mistake last time. So 8 plus, now plus 7 into x is plus 7x. 7 into minus 4 is minus 28. Now this becomes a normal sum where we have variables on both the sides. So let's get all the variables on one side. Now what I would suggest is, before you go ahead and get all the variables on one side, first simplify the left hand side and the right hand side, alright, so that the number of terms reduce.
Yeah.
So if you notice, there are like terms over here. I can add 2x and 3x, correct, over here. So 2x plus 3x I can write it as, and minus 10 and minus 6. So if I take minus 10, I take minus 10 and minus 6, then minus minus, what do we do? Add, and we put a minus sign. So 5x minus 16. So see, it becomes easier for us to solve, so that what happens is, when we are transferring terms from one side to another, we don't miss out on any terms, or the number of mistakes that we can tend to make can reduce to 0. Now over here, I can solve 8 and minus 28. So 8 minus 28 will be minus 20. So I can write this as 7x minus 20. Done?
Yeah.
Now it becomes easy. I can take either 5x over to the right hand side, or 7x to the left hand side. Now let me take 7x to the left hand side. Purposely, I just want to show what happens when I take a bigger number to the smaller number. So 5x minus 7x will be equal to minus 20. Now minus 16 will go over there, it will become plus 16. Now what is 5x minus 7x?
Minus 2x.
Minus 2x. Minus 20 plus 16, minus 4. Now I will take this minus 2 over to the other side. Now remember, just because it is minus 2 does not mean that this is under subtraction. It is still multiplication, because it is minus 2 multiplied by x. So when I take it to the right hand side, it will become division. So x will be equal to minus 4 divided by minus 2. And hence we will, minus and minus will get cut. 2 ones are 2 twos are. And hence x will be equal to 2. Is that absolutely clear?
Yeah.
Yep.
Yes?
Yeah.
Okay. Shall we look at a few more sums? Now, let's look at equations involving fractions. Equations involving fractions. Alright? So let's take a simple example. X upon 5 plus x equals to 12. Now if you notice, both the variables are on the same side. And here you have a fraction in x upon 5 plus x. Now how will we add these two variables?
Find the LCM.
Correct. So first we need to make it a common denominator.
Yeah.
Right? How do we turn it into a common denominator? By taking the LCM. So one thing you need to ensure that when we write x, it is as good as saying x upon 1. So it's as good as saying it is x upon 1. Right? But it's just that we don't write it as x upon 1. Alright? But you can assume it as x upon 1. And if you get confused, then you might as well just in the next step write it as x plus 5 plus x upon 5 plus x upon 1 equals to 12. And then you take the LCM of 1 and 5, that will be 5. Hence, I will multiply the numerator and the denominator by 5. Hence, I get x plus 5x whole upon 5 equals to 12. So now this is my common denominator. Now I can add the numerators. So what is x plus 5x? 6x. So I will get 6x upon 5 equals to 12. Now I take 5 over to the other side. Since it's in the denominator, when it goes in the on the right hand side, it will be in the numerator. That means it will become multiplication. Right? So this will become 12 into 5. At the same time, this 6 that is there can also be transferred. Now since here it is in the numerator under multiplication, it will become division under the denominator on the right hand side, as the denominator on the right hand side. And on the left hand side, what we will be left with is x. Clear till here? Yes? Now it's simple. 6 ones are 6 twos are. Hence, what is the value of x? 2 into 5, which is 10. So therefore, x equals to 10. Are we clear? Yes? Now, shall we look at two more sums, two more variety of sums, right? Okay. X minus 1 the whole upon 3 minus 2x minus 3 the whole upon 5 equals to 1. Now when we get this type of fraction, our method still remains the same. We first take the LCM to make it a single common denominator. So what will be the LCM of 3 and 5? 15. Yes, it's as good as that, but I prefer taking the LCM, alright, because at times in cross multiplication you may get very big values. Like let's say if I have the denominator could be like 12 and 8. Then you cross multiply 12 and 8, unnecessarily you get bigger values. But if you take the LCM of 12 and 8, you'll realize it's 24. So then the numerator of one fraction will be multiplied by 2 and the numerator of the other fraction will be multiplied by 3. Yeah, so always take the LCM method. That's easier. Having said that, you're free to just simply cross multiply. That also will work. It will boil down to the same value. So LCM is 15, so I will have to cross multiply. So this will be 5 into bracket x minus 1. Please ensure you do this particular step over here. Means you're multiplying by 5 basically. So if you want, you can put it over here into 5. Bracket into 5. This will be bracket into 3 into 3. Yeah. Hence, 5 into x, I will get 5x minus 1. Now be careful over here. There is a negative sign, a subtraction over here. Whenever there is a subtraction, I would suggest keep your answers within the brackets. Now here I will multiply 2x minus 3 by 3. So this will become 6x minus 9. The whole upon 15 equals to 1.
Also give you 5, right?
Yes, sorry. Thank you. So this becomes 5x minus 5 because I will multiply this 5 with the entire bracket. Alright? So now when I open these brackets, there is a minus sign outside the second bracket, so signs will change. The signs of the first bracket will remain the same, so this will remain 5x minus 5 minus 6x plus 9
upon
upon 15 equals to 1. Now we can solve it. What is 5x minus 6x?
Minus 1x.
Minus 1x. Or you can just simply write it as minus x. And minus 5 plus 9 is
Plus 4.
plus 4. So minus x plus 4 equals to, I can take this 15 over to the right hand side.
15.
Here it's in the denominator. Here it will be in the numerator as a multiplication. Right? Now I can take this positive 4 plus 4 over to the other side. So I'll be left with minus x equals to 15 minus 4. So minus x equals to 11. But we need the value of x. So if minus x is 11, what would be the value of x? Minus 11. Clear? Understood?
Yeah.
The last sum. Now, let's say if I have y plus 15% of y equals to 46. So let's say I have this particular question. Right? This involves a little bit of percentage as well. Right? Now how do you convert a percentage into a fraction? 15 upon 100. Of means multiplication into y equals to 46. So now I will simplify 15 upon 100. Both are divisible by 5. 5 3s are 20s are. So what am I left with? Y plus 3y upon 20 equal to 46. Now I take the LCM. Remember, this y can be written as y upon 1 or can be assumed as y upon 1. Hence the LCM will automatically be 20. That means I will multiply this particular y with 20 into 20 into 20. Correct? And hence I will get 20y plus 3y the whole upon 20 equals to 46. So what is 20y plus 3y? 23y upon 20 equals to 46. Now I can take this 20 which is in the denominator over to the right hand side as a numerator, and this 23 I can take it over there on the right hand side in the denominator as a division. Hence I will be left with y equals to 46 into 20 upon 23. Now before you multiply, check if 46 is divisible by 23. It is. 23 2s is 46. So 23 1s are and 23 2s are. Hence I get y equals to 2 into 20 and therefore y equals to 40. Clear? Understood? So these are the different varieties of simple equations that we can come across.